Hi, good morning. I am Jagdish, Professor of EC Department, SNS College of Technology, Coimbatore. And in the previous episode, we have discussed about the introduction about microwave frequency systems. And in this episode, we are going to discuss about the topic scattering parameter and the properties of S matrix in the optical and microwave engineering video lecture series. Come, let's get into the topic. So imagine a water wave in a pond. What happens when you throw a stone, single stone, small stone? It will create some ripples. So this is actually called as a scattering. So here, according to the scattering, it will have a incident wave and reflected wave and transmitted wave. It means incident wave means the waves you create. Reflected wave, the waves bounce back, and transmitted wave passing through. So this is actually this is an imagination to understand the S parameter. And what are all scattering parameters? So S parameter provide a black box summary of how signals behave in a microwave network. Microwave network which has active components and as well as the passive components. So this S parameter, from this S parameter, we are going to study about the S parameter property and the S matrix properties, right? So this scattering means that the transmission, reflection, and refraction, diffraction, all together called as scattering. Because in already in the previous episode, I told that microwave frequencies is a very large frequency, gigahertz range of frequency, and able to used in satellite communication also. So that behavior of the signal can be understood only by means of the scattering parameters. So it is, for example, the scattering parameters S11, that means that there is a reflection of input. S21, that is a transmission, and complete matrix is there. So this is the S parameter, importance of S parameter. So waves hitting a glass window, that is reflection. Some wave bounce back like your reflection in the mirror. This is the echo you don't want the communication system. So that is defined as S11, where S1 is nothing but of S11 is nothing but of S1 is output, then second one is the input. So transmission means S21. That means first port to second port. The wave traveling to the second port. So this is the transmission, and S1 is a reflection. So visualizing the S matrix as a traffic map. So that is wave enters at port J, and device process the signal, and wave emerge at port I, and S parameter quantifies the relationship. So this is, see, when you see the typical traffic in the university, you cannot able to segregate the vehicles, which vehicle is going in the direction and everything, right? So to systemize the concept, the signal concept, microwave frequencies, so we have this S parameter. So building a simple two-port network model, that is wave enters door one, mirror reflects, wave exit door two. That's it. So this is actually, if it is reflect back, that is the reflection, that is called as an echo. So that we don't want, because our aim is to transmit the signal from one to another place. That is door one to door two. So this is the right door. So but anyhow, in a practical scenario, the reflection will be takes place, so that will be considered when we are deriving the behavior of microwave signals. So some properties of S matrix is square. S matrix is a square matrix, that is n into n. That is n row and column will be similar. And reciprocity property, that means Sij equal to Sji. That is reciprocity or symmetric property. Then energy conservation. That is total outgoing wave power must be less than or equal for incoming power. No magic energy is created. Physics always wins here. So how do engineers measure S parameter? So that is a VNA, that is a vector network analyzer is there. That is a tool we can analyze the S parameter from this one. So here the steps are: generate precise test signal, measure amplitude and phase, calculate all S parameter automatically, display results in real time. And VNA measurement setup in action. It's a calibration first step, then device connection, signal sweep, and data analysis. From waves to design thinking, as we already discussed in the previous slides. So this S parameter and the properties of S parameter, which is coincident with the our design thinking approach, that is displayed in this slide. And the mind map. So we have covered fundamental concepts of S parameter, key parameters, and S matrix properties, and analogies and measurement. That is a VNA that we covered.